Good morning, Algebra 2. Let's get started on Unit 3 notes, Day 2. We're going to graph x is greater than 1. You could start by putting a dot on the x-axis at 1 and then put dots vertically above and below. Now, this is not an equal to statement, so I'm going to leave those as dots. I'm not going to connect them. Since it's an inequality, you now want to shade, and all the values where x is greater than 1 is this direction. So we want to shade everything over here. Now, y is greater than -1. Well, this is where y is -1. And now we want to draw dots to the left and to the right of that. All the values where y is greater than -1 are above that line. So let's shade up here. And your solution is where these colors meet. So this region right here. That's how you graph them. Example 2a. Tell whether the ordered pair is a solution to the system. Coordinate 0, 0. That is right there. That is smack dab in the shaded region. So yes, that is a solution. -2, 1. So let's go left 2, up 1. And if you'll notice, we fall on a dashed line. So no. If it was solid, then yes, but it's dashed, so no. When they give you a set of ordered pairs and they want to know, is the set of ordered pairs a solution to the system? We're going to use substitution. This is the x value. That is the y value. So let's substitute them into this system first. Instead of 3 times x, we're going to do 3 times 1. Minus. Instead of 2 times y, we're doing 2 times 2. And then less than 1. Now let's simplify this. 3 times 1 is 3. Minus 2 times 2 is 4. 3 minus 4 is -1. And now we ask ourselves, is -1 less than 1? Yes, it is. So far, it is a solution. But it also has to be a solution for this one too. So let's check that. X, we're going to substitute 1 plus 3 times y, but we want y to be 2, greater than or equal to 5. I'll start doing our math. 1 plus 3 times 2 is 6. 1 plus 6 is 7. And now we ask ourselves, is 7 greater than or equal to 5? Yes, it is. Since it is true for both systems, then yes, that ordered pair is a solution. Example 3, we're going to graph the system starting with y is less than 2x plus 1. Near y-axis, put a dot at +1. And now our slope is 2 over 1. So up 2, right 1. Up 2, right 1. Now, this is not an equal to statement. There is no line underneath the inequality. So I'm not going to connect these. I'm just going to leave them as coordinates. All the values where y is less than below that direction. So you would want to shade over here, all this stuff. And now we're going to graph y is less than or equal to -x minus 3. Let's go to where y is -3. And now our slope is -1. So down 1, right 1, down 1, right 1. This is a equal to statement. There is a line below the inequality, so we need to connect these dots. All the values where y is less than below the line, so you want to shade all this region, then your solution lies where the colors meet. They meet in this zone here. That is our solution. All right, let's graph. Y is less than or equal to negative 3 over 4x plus 1, starting with the y-axis at positive 1. And now our slope, negative 3 over 4. Down 3, right 4. Down 3, right 4. This is a equal to statement. So we are going to connect these dots. This is a less than statement, so all the values where y is getting smaller below the line. Now, before we can graph the next system, we have to convert it to y equals mx plus b. Slope-intercept. You're going to start by subtracting 3x from both sides. Positive 3x was on the left side of the inequality. We subtracted it and moved it over to the right side. Now divide everything by 4. And that's the line that we need to graph. Let me write it. Okay, starting on the y-axis at positive 4. 1, 2, 3, 4. And now our slope down 3, right 4. Let's see, this is not an equal to. So we could do some dashed lines. I don't really have enough points, so I'm going to do some dashes. Ooh, looks like we have a parallel line here. This is a greater than, and all the values where y is greater than are going to be above the line, so we're going to shade this way. And then, as you can tell, the colored regions, they're never going to meet. So this is a no solution. Example 4, we're going to start by graphing y is less than or equal to 4. So on the y-axis, 1, 2, 3, 4, go to positive 4. This is going to be a horizontal slope. So you could put some more dots to the left and right. So this is going to be a solid line. So I'm going to go ahead and connect these dots. All the values where y is less than that direction. And now we can graph the absolute value. Y is greater than x minus 2 plus 1. Your vertex, looking inside the absolute value, is right 2 up 1. That's where our graph begins. Right 2 up 1. Now look in front of the x. There's nothing there, so we're going to pretend our slope is 1. So go up 1, right 1, up 1, right 1. Back to the vertex, and this time up 1, left 1. Now then, this is not a equal to, so don't even connect those dots. Just leave them as ordered pairs. All the values where y is greater than, going to be above the vertex. And the only place where these colors are going to meet are this area right here. That's your solution. Over here, y is greater than x minus 1. Start by putting a dot at negative 1. And then your slope is 1, so up 1, right 1. This is not an equal to, so we can not connect those dots. All the values where y is greater than x, where it's greater than that direction. Okay, now we're going to graph the absolute value here. Looking inside the absolute value, our vertex is -2. There's no number outside to the right, so -2, 0. That's where the vertex is. So go left 2, put a dot, look in front of the absolute value. We're going to use that to help us plot all our other dots. From the vertex, we're going to go up 1, right 2. 1, right 2. Back to the vertex, up 1, left 2. This is an equal to statement, so let's connect these. And now for shading, all the values where y is less than is going to be below our vertex. Here. A lot going on with this graph. So far, the only area where they share space is right around here, this region. Let's keep that in mind. And now we can graph x is greater than or equal to -2. Don't worry about that y. It's not a part of the inequality here. It's just letting you know that this is the y-axis. X is greater than or equal to -2. So let's go to where x is -2. And then since it's an equal to statement, we can just go ahead and draw a line vertically. And all the values where y is greater than -2 is this direction. So all this over here. Woo, there's a lot going on. And it's kind of hard to tell. But the area where they share space, where all these colors meet, that area right there. Okay, example 5. Write a system of inequalities for the shaded regions. Why did I say for? For the shaded regions. Let me learn you what for. All right. If you notice, we have 4 lines here. We have 2 vertical, 2 horizontal. So how about we start with the horizontal? This horizontal line is going through the y-axis at 2, 3, 4, 5. Since they're shading below the line, that's going to be less than. Since it's a solid line, equal to, and then it was going through the y-axis at 1, 2, what was it again? 1, 2, 3, 4, at 5. So y is less than or equal to 5. Now this one here. Wait, that's the x-axis. This is really hard for me to read. Looks like this line here, this horizontal line, is going through the y-axis at -1, and they're shading above the line. Y is greater than or equal to -1. Okay, now let's do our vertical lines. Looks like we have a vertical line going through the x-axis at -2. And we're going to make that greater than or equal to -2 because they're shading to the right of the line and the line is solid. And then lastly, it looks like we have a vertical line going through the x-axis at +2. X less than or equal to 2. So we have now written a system of inequalities for each of those shaded regions. This one here. Let me start with the easy one. You see that horizontal line? That looks like that's going through the y-axis at. Notice they're going by 2s. Looks like they're counting by 2. So it looks like it's going through the y-axis at +4. Y less than or equal to. Oh, goodness. Sorry, I just knocked something over. Okay, this line here, our y-axis, remember, it looks like they're counting by 2s, is going to be -2. And up 1, right 1, up 1, right 1. Our slope is going to be 1. And they're shading above that line. So y is greater than or equal to x minus 2. And then this line here Y is greater than or equal to, just notice that the slope is negative. It's a negative slope, so negative x minus 2. Example 6. You are selling pizzas to raise money for a school field trip. Cheese pizzas cost $8 and pepperoni pizzas cost $9. You need to sell at least 2 of each pizza type, and you want to sell at least $150 worth of pizzas. Write and graph a system of linear inequalities that describe the information given above. You sell, and then, well, we'll get to part B in just a second. Okay, they told us that we had to sell at least 2 of each type of pizza. So we're going to do C needs to be greater than or equal to 2, because we want to sell at least 2, but we can sell more than that. And then P for pepperoni, P is greater than or equal to 2. And then they told us that we want to at least make $150. Well, since cheese costs $8 and pepperoni costs $9, this is how we're going to set that particular portion up. And now let's graph. Notice this is our C axis. And if we want C to be greater than or equal to 2, then we're going to go to where 2 is on that C axis, and we're going to draw a vertical line. Next, P is greater than or equal to 2. This is the P axis, so let's go to where 2 is, and now draw a horizontal line. And I suppose I forgot to do my shading. I should have done my shading. Okay, so whenever we graph this vertical line, all the values where C is greater than that are going to be over here. And when we graphed our horizontal axis, all the values where P is greater than 2 are going to be above the line. All this here. Now I'm going to use the intercept method to graph this line here. If I do 150 divided by 8, that's 18.75. I did 150 divided by 8. So on the C axis, let's put a dot at about 18.75. Let's just say right about there. Now I'm going to do 150 divided by 9. That's 16 point, let's just call it 16.7. I did 150 divide 9. So on the P axis, let's put a dot somewhere at about 16.7. So right about there. And now we're going to connect these two dots. All the values where it's greater than are going to be up here. This area is where all 3 of these shaded portions meet. So this is where our solution lies. Up here. You sell 12 cheese and 10 pepperoni. Did you reach your sales goal? Well, let's see. Let's go right to where 12 is and up to where 10 is. This ordered pair right there. Since we're in the shaded region, yes, we did. That is your answer for part B. Good job, Algebra 2.